Now for the type A format, the question is to come in this form, whereby you'll be asked to, let's say, you'll be given a particular quadratic equation. Let's say we are given that same equation of 2x squared plus 5x minus 3. Now, some questions will now be given. Given a quadratic equation, evaluate the following. You might be asked to evaluate 1 over alpha plus 1 over beta in this case. Another one, you might be asked to evaluate alpha squared plus beta squared, and so on and so forth. You can go ahead with that. There's another question which is to come in this format, whereby you'll be given a quadratic equation. Okay, let's say you're given a quadratic equation of 2x squared plus 5x minus 3. And then the next thing you'll be asked to do is that you'll be asked to form a new equation. You'll be asked to form a new quadratic equation such that the roots given are, let's say you'll be given something of this nature. Let's say alpha squared, and this one, let's say you have beta squared. You're not given a new root. You'll be given a quadratic equation. You'll be asked to generate a new equation, like form a new one, given some certain roots. So if you have any questions based on this type B, you should know what I'm trying to say. But please take note, to generate a new equation, there's a general formula for it, and the general formula is x squared minus the sum of the roots given. You sum these roots, the sum of the roots given, and this is the root given. That is, you have alpha square, you have another root given, which is beta square. So you have to sum. This is sum of the roots given, and this implies that you have alpha square plus beta square in this bracket. So I repeat, the formula is x square minus sum of root given of x, then plus finally with product of the roots given. Okay, that is, in this case, you now have alpha square times what? Times beta square equals to 0. So that's all. So in this case, if I want to solve this question now, that will be x squared minus the sum of the root given. This is the root given to me, so I have alpha squared plus beta squared. You close it, then you put x plus, what about the product? You multiply the roots given together. That's alpha beta all raised to the power of 2, alpha square beta square. So in this case, I've not actually explained what alpha square plus beta square is. The sum of squares of the roots. I've not given it. There is an expression for this, whereby I'll write that one later so that you take note of it. There's the way we used to do it. And in this case, there's an expression for this one which says alpha square plus beta square is always alpha plus beta all squared minus 2 alpha beta. Don't worry, I will explain it better in the next video. Okay, and then where alpha beta is c over a, right? Remember that is the expression we have for it. So in this case, alpha plus beta is minus b over a. Remember, then you need to square it. 2 alpha beta is also what? C over a. Then you put your x plus c over a squared equals to 0. So we end up having x squared minus b over a, which implies b. What's my b? Now that's why this equation is given here. That's where you're going to generate your a, b, and c from. So minus b over a squared means b squared over a, and b is 5. That means you have 5 over a is 2. 5 over 2 squared minus 2 times, and here in this case you have c over a. C is minus 3 and a is 2. So then you have x plus, here in this case c is minus 3 and a is 2. Then you square it equals to 0. So you should be able to simplify this from here. 5 squared is 25 over 4 plus 2 cancel 2. That means minus 3 times minus 3 is plus 3. Then of x, then minus 3 over 2 squared means you have minus 3 over 2 times minus 3 over 2. That's 9 over 4 equals to 0. So whatever I have left now should be in this form. The SCM here is 4. 25 plus 4 times 3 is 12. You have 25 plus 12 times x plus 9 over 4 equals to 0. So if I try to clean this off,